handlers. Let's look at handlers in Rust. So we will look at closures inside functions. If you've ever looked at Axum or ActiveWeb, you'll know the handlers. You'll be familiar with the word handlers. But let's actually write our own. And because it's cold, I don't actually want to keep my hands on the desk very much. So let's just start writing some code. And we can talk about what's going on as we go. So this is going to be more of a demo, I guess, or more of handlers two, just in case I'd already had a handlers one. Let's go into main. Okay, so what we're going to do is we are going to we'll build the example that I've been practicing with, which seems quite real world, because the problem is if you don't make it real world, you'll end up with, it's called overfitting, isn't it? You'll end up with an example in your head which you know inside out, but if push comes to shove in an interview or in a job, you'll actually only know the example. So this is like a database user. It's self-explanatory. What else do we have? We'll have whether it's active or not. So ball, and then we'll just I should set my Vim to do that for me automatically. Right, need a key binding for cargo format, don't I? Let's build the function. So this will be, I think this is also called a dispatcher, but that's getting quite theoretical. Let's just stick with building something, and then we can see what breaks, see what I've forgotten, see what is kind of needs more explanation. So we'll call it process raw text. I don't know if you can see, but I've got no notes, or I'm not looking at any other screen. I've only got one screen, so this is all from memory, but kind of learned as well. So I'm going to create two generics here. One is H, which will be the handler, and the other is R, which will be the result. And typically, whenever I've done generics, I've always kind of done T's and T or F for function. So as I say, in the real world, you come across S, U, T, etc. So let's try and move from theory, tutorial hell, to actual real world names and representation. So we'll have some input, which can be string slice, and we want a handler, which will be of type H, capital H. Then we want to return, so a generic a result, which can be a generic R, or if it's an error, then it will be string. So this is the bit that starts making Rust look to a learner. This is what makes Rust look more complicated. It's when you start using generics, and say if you've written Python all your life, you probably not not have to use generics quite so much. But if you were building a library, this is where it would really come into its own. So where H is of type, we'll do FM once because we want to pass the value. And then we'll take a string. So this will be this is what the closure takes. So the first line is the function, and then what we're saying here is H, which is the handler, and the handler will be a closure. So this can take a string, and it's going to return a generic type R. I think that should work. And then we actually do our actual function. And at the moment it's complaining because we're not returning anything, but pretty standard. So let we'll trim it. We'll just do like an operation first. So we'll take the input text and then we'll do input dot trim. And this is just to show that there's kind of some cleanup stuff going on and other bits and pieces. And then we'll actually use our handler here, which will be we'll have some error handling here as well. So if input length is less than 3, turn error as well. We can do that in a minute, but let's do the handler because that's the interesting thing here. So we'll do result equal okay, handler, and this is this is effectively the framework which the closure will go into. So we can put trimmed there, but it needs the closure needs a string, so we'll have to do into. Is that happy? Will it be happy? Yeah. So we're not actually doing any manipulation because the whole point is what we want to take some user input, like a username, and then we need to put it into the DB user struct. But the purpose of using the closure is that if you wanted to do something different as a second operation, you could call process raw text again and use a different closure inside that function. So we need to return a result, so that's okay. And we need to return res just there. And that's accepted it, which is nice. Very minimalist and not proper usable code really, but it will compile, which is the name of the game here. Especially, I live in Europe, and yeah, what with everything going on in the world, our lovely leaders have decided to make us very cold. And if you come from anywhere else in the world, which has got more natural resources, I have no beef with you. I have a beef with our leaders who seem to think we should take the brunt of their decisions. Right, so let's inputs equal, and then we just do just a moo, which I always do because it's good for alliteration. In fact, no, we don't need to do it as a string. Right, so it's a string slice. Next, let's use the function, and then we will put the logic into the closure inside that function. So we've only done half the job here, but the beauty is that if this was a library, process raw text can run whatever you want to do. So if you want to change it to uppercase, if you want to add something to it, manipulate it, whatever. So we've got the input, which actually is already called input, and we've got the handler. So now this word handler, which is obviously the placeholder, we need to start doing stuff. So this is where we start our, we can just do T for thing maybe. That's right, it doesn't need to be input. So we can then, we've given a name to the thing that we want to get out of it. So we will now do DB, we'll create DB user struct. Oh, that's great. It's putting all on the same line. We'll create the DB user struct, and in there we will say active is true, and then the name is equal to t, which is what we've passed into the closure, which is from the input, which is Mr. Moo. Right, getting there. So we're on the final straight now. So if we'll get an error here because it needs to add. It'll ask us to add debug to. It'll ask us to add debug to the struct, but that's not difficult, is it? There we go. Derive debug. So I don't always code like this, but this is just with cold hands and it's with big font for the video. So yeah, I know this seems quite clunky, but right. Okay, that's worked. So it's just moaning about stuff not being used. So DB user, the closure has returned a. Let's pass it some more. So yeah, so let's put in a space in there then, or a couple of spaces. And then the trimmed will work. Yeah, the trimmed works. So you see what we've done? The trimmed, which is not specific to our business logic, whatever we pass in to the function, process, raw text, whatever we pass in there will always need to be trimmed. The handler, that's just taking some input, and when we call it, so handler only, that's a name which exists in the function, and then there where we use it. And it exists here, but in kind of type hint name only. But what we're really doing is passing in a string, and then we're taking that string and using it within the struct that we're creating, which is what the closure doing. The closure, as you know, closures really come into their own when you're doing Tokyo stuff because it captures your environment and so on. And also, closures are good for doing stuff with state, whereas if you use function pointers, they don't. They're very. But the benefit of a function pointer, as far as I know, is that it is compatible with FFI, ABI, so it's very more compatible with C, C++, and the like. So yeah, obviously we'd have a bit more if trimmed less than 3. Let's return too short. Expected static string. Oh, expected string found I30. Oh, so trimmed dot length less than 3. There we go. Let's change it to 9. We should get an error. We go too short. Back to 3. what have we done? Let's just do a recap. We've built a struct, we've built a function. The function takes a closure, so that's a handler. The handler, so a handler is not a keyword in Rust. You'll see it widely with Actix or Axum and much web stuff, but the handler is um, taking care of all the nitty gritty stuff for you. So the beauty of it is if we did this again, rather than returning DB user, we might say, oh, we don't want to do that anymore. Let's just, you could just return T. Quite why you'd want to do that, I don't know, but. And why is that complaining? Oh, it expected the result type's wrong now. Yeah. In fact, it's not even returning a result, is it? So, yeah. Um, wonder what would happen if you wanted to append something to the name. We would just use format. This is going to get ugly, folks, but just bear with me. Tease. Let's just do format. There's probably a better way to do this, but let's just run with this just for fun. For fun and definitely not for profit. There we go. So you see there we've got the name now. Name. You wouldn't have name in there twice, would you? There you go. So probably the best thing to do is try and type this kind of stuff from memory as you learn it. And the key things here are becoming familiar with using your own generics. Your own, as I showed in the previous video, you can use whatever letters you want. The compiler kind of strips those off and does its clever stuff anyway. So when you're writing your own code, don't just stick to capital T. Because if you do, yeah, you can learn Rust for a long time just using capital T, and then you'll come across production code, other people's code, and then they've used. So these letters, the H and the R, obviously the first letter of what they represent. So H is the handler and R is the result. So if you learn nothing else from this video, just remember that you can pick whatever capital letter you want for your generics, but you can also make them slightly meaningful. And again, the whole point of writing meaningful code is then you don't need so many comments. Do you even use comments? I'd be interested. I mean, no, obviously with something more complex you would. But well-written code should document itself. Arguably, you may not agree, but I mean, process. You've got DB user, that's a database user. You would not really need to put a comment here saying database user struct. Name is the name of the database user. Active is whether they're active or not. Yeah, interesting. So I really just put handler here just because I was typing what I was thinking. To be honest, you don't really need that there. Yeah, this takes a bit of getting used to. I've been learning Rust for a while now, and really I've only really just forced myself to start doing this as if it's second nature. Having come from a Python background, this was quite daunting. To be honest, the generics up here, not too bad. But it's just building the mental model. So remember that this line is the function, and this line is the closure. So if you remember the top line function, second line closure, and as and when you get to using function pointers in functions, then it's not that big a jump. But yeah. Also, you've probably, if you've looked at done tutorials with the closures, you will have always seen F. So you'll have seen an F in here. Because that's not, if you see F, you know it's a closure. So I mean, answer in the comments, would you actually even use an H there, or would you use an F? There we go. That is a very quick and dirty look at using closures in functions, but from the point of view of handlers. The handler abstracts away the business logic so that or it abstracts away what the user's trying to do, such that this could be written for a library. And as you progress, you will start to become more aware that writing an app is different to writing a library and writing reusable code. That's a learning curve, and I guess we're all on that learning curve. Then that also leads us on to whether you use static dispatch or dynamic dispatch, and also generics versus traits. Once you learn generics, you will likely use them everywhere. But once you understand the pros and cons for maintaining, it's easier to maintain something which uses dynamic dispatch. Compile times for using static dispatch can be longer. Again, it's pros and cons, but be aware that there's a time and a place for generics, there's a time and a place for dynamic dispatch, and also there is a time and a place for hybrid approach where you use both and you write your code with a bit of static dispatch struct in an impl, and then you use that higher up with some dynamic dispatch. There we go. Don't just listen to my ramblings. Go and try it. If you want to see my articles, I try and write the article. I ask questions to the inevitable AI. I get it to make me an example. I test the example in Vim or near Vim. I'll get a second opinion from another AI. I'll then get the best of both, and I'll put that into Rust Playground. And then once it's gone into Rust Playground, I'll probably build a 400-page WordPress article for me to refer back to. And I think it's important to go back to stuff because, and also make your paper notes. um, I think it sinks in sometimes if you just do I wouldn't say scattergun approach, but you do it all. You do Rust Playground, write some notes, come back the next day, or you leave the notes lying around, and then you see them there, and then you think, oh yeah, I probably should go back and just check I can still remember that. I think 3 times is a good rule. So if you learn something one day, then 3 days later you probably should be approaching stage where you're starting to commit to long-term memory. Um, there's so much to learn that you probably don't want to just keep practicing something over and over again, because then your brain almost reaches the point of overfitting where you remember one example impeccably, but you'll short circuit a fuse in your head as soon as any of that deviates, or as soon as any real world problem deviates from what you've memorized. So um, I think this is a good example because it starts rather than just your standard T, it starts putting in kind of real world names and things. So what do you think? Let me know in the comments. Everyone says this these days. So do you know why that is? It's engagement farming. So I've said it today, tongue in cheek, but if you watch many YouTube videos, um, you will notice people asking questions is to get more comments, because the more comments you got is better for the algorithm. So I will try not to do that because I'm not indulging YouTube. They're a platform that I use um, as a backup for my learning. So as I learn stuff, I'll make a video and then it's on YouTube. And if I ever come across a problem and I'll think, oh, I did it, didn't I didn't I do something about that once? And then you go back. So use YouTube. Don't let them use you. They they are very expensive. I think these platforms are becoming too expensive. And with whilst AI is free, other than for entertainment or for historic reasons, because you've followed someone for a long time, why would you use YouTube with lots of adverts, 30-second adverts for Monday.com or whatever, Wix, one of these dreadful sites? Why would you want to use? The only reason you would use or use YouTube is if you know that the creator, the content creator, if they're kind like me, then they will put links to the GitHub repo, they'll put links to Rust Playground. I'd encourage anybody who makes YouTube videos to share the examples from their videos in Rust Playground, because it's just nice, cool. Um, yeah, kind of considering what to attack next, and I think some kind of intermediate or more advanced error handling, because that's the one thing that always, from my point of view, it's always the one thing which gets neglected. Um, creating your own types, so you create your own error type, and then you can reuse that. Anyhow, I don't think it's okay for using in an app, but I gather that for using in like a library, then it causes knock-on effects for your users. So yeah, error handling. I don't think you can ever have enough error handling, or and then really go into send and sync and completely learn the difference or learn what they apply to. So even if you were in an interview and someone has said, well, what's the difference between send and sync, then um, send is moving between threads and sync is sharing data across threads. I think sometimes it's beneficial to know definitions of things. For instance, if whether it's in an interview, whether it's doing a tutorial, whether it's talking to other developers, you might find you can code okay, but when you are in a room with other developers, you'll be I wouldn't say intimidated or imposter syndrome. That's maybe exaggerating, but I think being able to be concise with your terms and terminology and definitions, and also for prompts. So if you talk to AI, Claude, ChatGPT, if you can create your prompt with the correct terms, definitions, so you're going to get a better output. So you could ask it to write some code, but use static dispatch or whatever. But um, you could ask it to use generics. Um, you could ask it to make your library more ergonomic. You could ask it to use function pointers, etc., etc. It's the more words you know, the more terms that you can define in your head accurately, the better it will be, even when you're using AI. So somebody who's an experienced programmer will get a better outcome from an AI prompt than somebody who has only been practicing for 6 months. Anyway, this was meant to be a quick video, but I just thought I'd capture some thoughts whilst at it. So thank you. Thumbs up. There's always one person who seems to give my videos a thumbs down, and yeah, I wish them a happy new year.